All right. Good afternoon. It is 12 o'clock. Welcome to this week's Iowa Learning Farm Conservation Webinar. I'm Matt Helmers with Iowa State University and looking forward to this webinar and appreciative to be able to get to moderate many of these. This week, excuse me, we have Dr. Richard Roth. Dr. Roth is Assistant Professor and Extension Nitrogen Education Specialist at Iowa State University. Been here not quite a year, I think, if I'm not mistaken, from Illinois originally. But Dr. Roth is going to talk to us today about how can cereal rye affect nitrogen cycling and crop production. So important topic for sure. As always, if you have questions or comments, please feel free to type those in the chat box and we'll get those to Dr. Roth at the end of the talk. And with that, Richard, the virtual floor is all yours.
Thanks, Matt. Hopefully we can hear me. Can you hear me, Matt?
Yep, I can hear you real well.
Okay. So so as Dr. Helmers mentioned, I'm Dr. Richard Roth. I'm in the agronomy department at Iowa State. And today we'll talk about understanding cereal rye nitrogen cycling, both the benefits and the risks. And so the first thing is kind of when I think about a cover crop system, I kind of think about pretty much four key elements that would make it a success. So the first is probably the oldest use of cover crops, right? And that's to prevent soil loss. We know that they do that extremely well. The second would be to prevent nutrient losses, specifically from like here in our Iowa landscapes where we have a lot of tile drainage. It helps reduce losses through tile drainage. But again, also coupled with that soil loss control, we can help with runoff losses of nutrients as well. Another aspect of cover cropping systems could be that it could help promote nutrient use efficiency. That's what we're going to talk about quite a bit today is how they can affect nitrogen cycling, and then finally would be producing competitive yield. So at the same level as if we didn't have them in our system. So you can kind of think of it in two ways. Number one is the environmental side, and then number two would be the agronomic side. So the first thing that we'll look at really quick is the environmental side of things. Now, I am going to take a minute just to kind of describe this trial layout that you have in front of you, because it is kind of the basis of a lot of the data that I'm going to show you. So this is in central Illinois. We have 15 individually tile drained plots, or acre and a half each. Came into a pretty good system already, where the farmer was strip till before corn, no till before beans. He was practicing 60%, so he's putting 60% of his nitrogen in the fall as anhydrous, and then 40% in the spring, also side dressing that as anhydrous. And so what we did out here was we put out five different treatments. One was a fall dominated nitrogen management system. So what I mean by that is that 80% went out as anhydrous in the fall and 20% as anhydrous at side dress. And then we had a spring dominated system. And so with that, basically the only nitrogen that hit the field in the fall was DAP. And then the rest of the nitrogen was side dressed as anhydrous. And then we had that system with and without a cereal rye cover crop. We also had a zero control out there where we didn't put any nitrogen at all. But I am not going to talk about that today. And so these were set up to monitor our tile lines automatically for us, so that we didn't have to go pull samples by hand. And so the first thing that we'll look at on this field is kind of how our cereal rye grew over the 5 years that I'm going to show here. So you can see we had on the left is I'm showing cover crop biomass. And then on the right, I'm showing cover crop cereal rye nitrogen uptake. And so on average, we had about 1,100 pounds to the acre of cereal rye biomass, but you can see we had, 1 year where we had less than 500 and another year where we had over 2,000. And then on average, our nitrogen uptake in that cereal rye biomass was about 41 pounds to the acre. So the next thing that we'll look at here is just the impact of that cereal rye on the tile drainage nitrate concentrations. So the blue lines on this figure are rainfall in inches, and then the black and the green is our nitrate concentration in milligrams of nitrate per liter of water that leaves the field. And the red line across is the EPA drinking water limit of 10 parts per million. So you can see that where we had a cereal rye cover crop, we were able to maintain our nitrate concentrations below that EPA limit almost the entire time that the study was taking place. You'll notice along the bottom axis there, the black bars. Those actually represent the corn or soybean growing season. So when the cereal rye is not actively growing, it's been terminated, it's no longer growing. You can see that even during that time frame, our nitrate concentrations, the majority of the time remained below that limit. So you'll notice here I'm only showing cereal rye versus no cereal rye, and that's because we didn't actually see a difference between our fall and spring application systems. And so a better look at that is here. So the circles are our spring application system, triangles are our fall application system, and then green is with cereal rye, black is without. And what we're looking at here is total load, so the total mass of nitrogen that left our system over that time frame. And you can see, if you look at the black, there's really not much difference between that fall and spring application systems. But when we added cereal rye to either system, we saw almost a 50% reduction in nitrate losses. If we think about why that's happening, this is a oversimplification, but one of the main reasons why this is happening is because cereal rye is extremely good at scavenging nitrogen from the system. So going in, pulling it out of the soil profile and working its way, assimilating it into its biomass, right? And so here what we have is across the top is plant available nitrogen, and across the left-hand side is soil depth. And so as you move down, we're getting deeper in the soil. And so you can see the green line, which is our cereal rye, is farther to the left than our control line, which indicates that we had less total nitrogen in the soil profile, which makes sense, right? We have something growing, it's actively taking nitrogen up, meaning that there's less plant available nitrogen, which is the form that we lose. And so less there, less to be lost. Okay, so we also looked at gas losses, and I'm not going to spend a lot of time on this, but the main takeaway here is that there's less of a definite answer when it comes to greenhouse gas losses, specifically nitrous oxide, and how cereal rye cover crops can impact that. So on the top left, figure A there is where we had a corn year. And you can see the cover crop reduced total nitrogen losses, so nitrate and nitrous oxide combined. And the proportion didn't really change in that year. But on the right-hand side, figure B was our soybean year. And if you look where it says cover crop, you can see that we actually significantly increased had a significantly higher nitrous oxide emissions in our cover crop system than where we didn't have cover crops. and we saw almost no difference in total losses. It was just the proportion, so where it came from, that changed. When you look at that across the average of the rotation, though, we did see a significant reduction in total nitrogen losses. But again, you'll notice where it says for the cover crop bar, you'll notice that the N2O emissions are significantly greater in the cover crop system than where we didn't have it. So that doesn't always hold true. There's plenty of papers out there that show reductions as well, but there's also plenty that show the same that we found. So essentially what I'm trying to say here is that we need a lot more work looking at how these cover crops and specifically cereal rye impact nitrous oxide emissions. So that's all great and well, right? But that was at the small scale, so acre and a half. The question is, does it scale up to a watershed? And the short answer is yes, it does. My animation didn't work there. So what I want to highlight is a couple things. So unfortunately, you can't see the actual bar graph behind here. We started the experiment in this watershed in 2014. And for the first couple of years, we didn't actually see really any impact of having cereal rye in the watershed. It took a couple of years to build up kind of a cumulative effect. And after about 3 years, we started to see reductions in nitrate loads at the watershed scale from where we had cereal rye and where we didn't. And over a 5-year period between 2018 and 2022, our average reduction was about 31%, which the table that I'm showing here is the Iowa nutrient reduction strategy. So it's a science assessment of how different practices should affect nitrate loads. And you can see I have highlighted there what cereal rye what it says cereal rye will do, and we're right in that range. And so we're kind of confirming what these reduction strategies are saying. Okay, so environmentally we're good. What about agronomically? It's a whole different story agronomically. So the first thing we'll look at, again, I'm talking about that plot study that I mentioned up front. When we look at soybean yields, we don't really see any impact of cereal rye on soybeans at that location statistically. But in general, about a two bushel per acre decrease where we had the cereal rye. Corn is a totally different story. So corn, this isn't what we want to see with corn, but unfortunately it does happen quite a bit. We saw about a 13% reduction in corn yield on average when we followed cereal rye. Again, that's not going to happen everywhere. It's not going to happen every year, but it is quite common across the Midwest. So we saw this data and we thought to ourselves, what is happening, right? We need to dig into it and understand what's going on. And so luckily we had the foresight to sample the corn plants across different growth stages. And so what we would do is we went out at the 6-leaf, 12-leaf, tasseling, and maturity stages for the corn, and we sampled whole plant. We took whole plant samples. So just cut the plant off at the ground, take it back to the lab and analyze it for nitrogen content. And what we found was that by maturity, we were ending up with about 22% less nitrogen in the corn where we had cereal rye versus where we didn't. Okay, so that is helps us explain what is leading to the yield reductions, but it doesn't necessarily help us explain why are we seeing this gap in nitrogen uptake. So one thing that I want to highlight here is that you can see the gap start to form there around the 12-leaf stage. And And so I want you to remember that V12 growth stage is where the nitrogen gap starts to occur. That will come back up in a second. Uh, okay, so the other thing that we looked at was how does it affect nitrogen use efficiency? So we saw about a 31% reduction in nitrogen use efficiency. So the way that that's measured is total nitrogen uptake uh, in the plant divided by the amount of nitrogen that we applied to the system, which in this case was 200 pounds of nitrogen. And another way to think of that is some people like to think of nitrogen use efficiency and how many pounds of nitrogen does it take me to produce 1 bushel. So where we had no cereal rye, we were about 0.98 pounds of nitrogen per bushel, and where we had cereal rye, we were about 1.12. So either way you look at it, you can kind of tell that we were less efficient in the cereal rice system. Okay, so the question is, were we just seeing that, right? We were at kind of a relatively small scale, right? Only an acre and a half. That was one location. So were we just seeing that, or are other people seeing this? And so during my PhD, I went out and I found data from all across the Midwest, and I ended up with 430 paired observations for corn. So by paired observation, I mean at that location there was one cereal rye plot for every plot that there was not cereal rye. And then I had 343 for soybeans. So we did some analysis on that, and on average across the entire Midwest, what we found was about a 6 to 6.5% reduction in yields for both crops, so corn and soybeans. For corn, that was about 10 bushels to the acre. For soybeans, that was about 3 bushels to the acre. And so we were kind of surprised, especially by the soybean data that we found. But it's not the first time or the last time that has been reported. And so the first thing, so this is older. So when the Iowa nutrient reduction strategy was first put out, they did mention that cereal rye could cause a 6% yield reduction. It has since been updated to reduce that number, but it was there when it first started. But there's a recent paper out of University of Illinois that looked over basically the same area where I went and collected like hard data from. They use satellite imagery to kind of try and predict corn and soybean yields and then how cereal rye is impacting them. And they saw about a 3.5% reduction for soybeans and 5.5 for corn. So, not too far off from what we found. And also, they're estimating based on satellite imagery versus I had actual yield data from the fields. Also, John Sawyer, who used to have my position at Iowa State, did a lot of work with cereal rye and corn. And he found about a 5% average reduction in yield across most of his studies as well. So I know I'm not talking to just an Iowa audience, but what I was interested in was looking at just Iowa data, and so bear with me. What I found was that for corn, about 45% of the time, yields were negative. And the average yield reduction across all 146 sites that I had was 2.1 bushel reduction. But you can see that there were some pretty significant yield reductions. Those are the blue lines there. And the other thing I like to highlight on this slide is that it didn't necessarily matter what our cereal rye biomass was. You can see that down on that far end where we had some of our larger reductions, we have biomass that ranges from, let's say, 200 pounds to the acre all the way up to 2,000 pounds to the acre, right? And so I suppose my takeaway there would be that the risk is always there. So um, the more important thing, rather than worry about how big the rye is, let's worry about how we manage it. Um, Conventional thinking would tell you as the system matures that the odds of seeing a yield reduction kind of go away. But the Iowa data that I just shared that spans 1 through 15 years of cereal rye in the same place. Um, and you can see that even as in the more mature systems, that risk is still there, right? So again, it all goes back to management. Soybeans, very similar story. Um, hmm, I'm not going to spend a lot of time on this, but I also during my PhD did an economic analysis based on that big data set that I pulled from across the Midwest, and found that basically until the system matures to about 8 or 9 years, net returns on average are negative. Uh, I don't have much more to say on that other than that's what I found for that specific data set, and that will not hold true for every situation or every farm, but it is what I saw. Um, I'm going to skip a lot of this. So it's not the first time that it's been seen. Here's another example. The solid black line is, or the red line would be our break even with a cereal rye and a corn soybean rotation. You can see most of the time it was a negative return. And then also some work out of Iowa State shows that in general, net returns with cereal rye in the system were negative unless it was being harvested or grazed. Okay, so what's happening? So ideally, what would happen, right? I said cereal rye is really good at taking up nitrogen. Ideally, it would give that nitrogen back to the soil, which then could be used by the crop. Unfortunately, what actually happens is that it doesn't give the nitrogen back very well. And so what's really going on is that we have this kind of tug of war going on between our corn crop and our soil microbes over the plant available nitrogen. And so to understand that, basically just you need to understand that the microbes need nitrogen in order to break down crop residues. And the only place that they can get that nitrogen is from the soil and from the plant available pool. And so essentially we're reducing the amount of plant available nitrogen because the microbes need it to break down the residues. And so here, this is a very quick, or what this is looking at is how much of the nitrogen actually returns to the soil from cereal rye and in what form. Basically, I want you to focus on the green bars here, which is plant available nitrogen. And so you can see that the far right bar, which would represent corn maturity, by corn maturity, we only see about 14% of whatever the nitrogen is in the plant actually become plant available. So in our system where I told you earlier, we had 40 pounds on average. So we're talking about 6 pounds became plant available, right? Um, okay, so so to explain that really quick, what happens is up front, we see a rapid bit of decomposition, right? So the microbes are working really hard to break down the residue. So at that point in time, they're pulling a bunch of nitrogen out of the soil profile. And then when we get to about the V6 stage, is where we see actually peak microbial activity. So that's where they're cycling the most carbon. And so you can imagine, okay, if that's the time where they're cycling the most carbon, they're also pulling the most nitrogen out of the soil. The other thing to remember is that that's when corn nitrogen uptake really starts to take off. And that's when we need nitrogen there for the corn. And then later in the season is when we see microbe activity actually related to releasing it in a plant available form. And so generally that happens after the plant has access to most nitrogen. I am about out of time, so I'm going to go through this pretty quick. So to put that very simply in a visual way, um, so cereal rye decomposition kind of peaks around the V3 growth stage, or the sizing of it. Okay, so the weather and everything acts on it, and then around V6, the microbes are really starting to decompose the carbon associated with that residue, which means that they're pulling the most nitrogen out of the soil at that time. And then you can see it overlaps with the nitrogen demand by corn, right? So that's kind of what's going on in the system as far as reducing nitrogen availability to our corn crop. Um, this is kind of just looking at how much of the nitrogen that is released by the cereal rye is actually used. And it's, don't try to interpret this figure, but basically what you should know is that corn and soybeans use about 10% of whatever comes out of the 10% of whatever's in the cereal rye. So essentially, if it is returned in a plant available form, the crop's going to use it, but there's just not much returned. Okay. Okay, so I'm basically out of time here, so I'm going to show. There's a bunch of different ways that we can kind of try to manage these nitrogen cycling effects that cereal rye has. So number one is we can try to manipulate nitrogen application rate and timing. Number two is that we can use this idea of precision planted cover crops to delineate corn and cereal rye growing zones. And then the last is just don't use cereal rye, right? Use a legume that will break down faster. I think I'm about out of time here. Give me like
It's
two
okay.
more minutes.
Yeah, just yeah, that you're fine.
Okay, so the first thing that we want to look at is what if we use starter nitrogen with cereal rye? So we had different starter nitrogen rates. We had 0, 50, and 75 pounds of starter nitrogen put out with the planter as UAN in place 2x2, so banded 2x2. And so when we look at nitrogen uptake with that, okay, so the first thing is where we in this experiment where we had no cereal rye versus cereal rye with no starter, we had a 13% difference in nitrogen uptake. But where we added at least 50 pounds of starter nitrogen, we were able to close that by about half, right? So we didn't totally overcome it, but we closed the gap a little bit. And when we looked at yield, we actually saw no significant difference in yield when we had that at least 50 pounds of nitrogen as starter. Though you can see kind of from the graph, the figure there, that there was slightly lower yields where we had cereal rye. So I'm not the first person to see this. John Sawyer, again, who was at Iowa State, saw this same thing using 2x2 banded urea as starter, and he looked at it across tillages, so no-till and then conventional tillage, and still saw reductions regardless of tillage. And then this is from the corn agronomist at Purdue University. He looked at nitrogen timing, so putting everything out pre-plant or doing starter and side dress. And when he put everything out pre-plant, he actually never was able to close the yield gap. But where he used starter and side dress nitrogen, he actually was able to close the gap and get equal yields. I'm going to skip that. Okay, I just want to very quickly talk about this idea of precision planted cover crops. So we're given a zone where we grow the cereal rye and where we don't grow the cereal rye. So this gives us some flexibility in the spring. It could help reduce that competition by the microbes, right? Hopefully in that corn zone, we have less competition going on. Can help with warming up in the spring, things like that. Also, we didn't do it in any of the experiments, but the strips could then be freshened using a strip freshener or just a strip till unit to warm up things even faster in the spring. And so we looked at a clover in this system that I want to talk about, a Balanza clover. And so this is a very cold tolerant clover. There's actually multiple cold tolerant clovers out there. There's Balanza clover, Bercine clover, Persian clover, and even some crimson clovers can also be pretty cold tolerant. Here's some pictures of what it looks like this is in southern Indiana, right? So more northern latitudes, you're not going to see this amount of growth, but you can still see very good growth. Um, the key with this kind of cover crop though is patience. So in the fall, it's not going to grow very much, just barely come out of the ground. But if you give it time in the spring, when things warm up, it will grow. So this is again from southern Indiana, but this picture is from Iowa just this April. And you can see again, pretty good growth we could get even at the more northern latitudes. Um, and last thing I want to show is how it impacts yield relative to cereal rye. So the red line here is our no cover. The orange and blue is where we have the clovers, and then the yellow and the gray is where we have cereal rye. And so you can see that competition for nitrogen is almost non-existent where we have um, the clovers. So if you focus on the left-hand side, you see that gap between where the cereal rye is and where the clovers and the control are. And what that kind of tells us is that number one, these clovers are breaking down quite a bit faster, and number two, it's likely that they're releasing nitrogen and more nitrogen in a plant available form. And so we actually were able to reach maximum yield about 50% or 50 pounds with 50 pounds less nitrogen where we had the clovers than where we had the rye. Okay. With that, I'll take questions. Here's my contact information. I'm happy to take emails or phone calls um, to answer any questions you have. And then, okay.
Let's go
So,
to, yep, I
yep.
can do those and you can catch your breath before we got some questions. And if others have questions, feel free to type them in. If you're on the webinar live and want to earn a CCA CEU, email Elena Whitaker, ALENAW at iastate.edu by 5 o'clock today. Include your name, the name you entered to watch the webinar, and your CCA number. Again, ALENAW at iastate.edu by 5 o'clock today. Next slide, if we can. If you watch this webinar live and are willing to fill out the voluntary demographics survey, we would greatly appreciate it from the Iowa Learning Farm standpoint. Only one survey response is needed for 2024 webinar. So if you filled one out, thank you very much. If you filled one out this year, thank you very much. If you're willing to do it, we'd appreciate it. You can scan that QR code or go to iowalearningfarms.org/survey. Again, iowalearningfarms.org/survey, and put a plug in for the webinar next week. We have Sheila Backer with Farmers Mutual Hail. Sheila's going to talk to us next week about how crop insurance ties into relay and double cropping practices. As we've gotten into our relay intercropping project, there have been some questions about that, and so I thought there might be some others, and I think a good opportunity to ask some insurance questions. Okay, Richard, there are a few questions here. I'll maybe start off that on the slide where you talked about your loads from your plots, there were somebody commented on the really high loads despite relatively low flow weighted annual concentrations. Did you have a lot of flow from those plots, or what's kind of the average annual flow for a lot of those conditions in Illinois?
Yeah, so during that time frame that I was showing, which was 2015 through 2019, I believe, we had relatively high amounts of flow during that time, especially like 2017, we had a lot of flow. and we had quite a bit of flow like during the winter months of several of those years,
Okay.
right? So that adds up where we had a couple years where the soil didn't necessarily freeze all the way, so we had drainage throughout the entire winter. Um, as far as average annual flow, I don't have an answer to that. But yeah, we our trials at that site run um fairly well, and we were getting pretty consistent rainfalls, and so we were never really experiencing too much of a too heavy of a drought scenario
Okay.
where an inch rainfall wouldn't cause drainage. So
Okay.
yeah, I don't have the exact answer on how much drainage, but we get pretty heavy drainage in that area.
Okay. All right. Um, Next one here is what is the C to N ratio for your cereal rye when you terminate it? Or
Yeah,
average C to N ratio?
that's a wonderful question, right? So cereal rye being a grass, we would typically think that it has a relatively high C to N ratio, but for all of that work that I just showed, we actually terminate uh, we generally terminate prior to stem elongation. And so what we have found to be our average seed in ratio across basically everything that I just showed there is somewhere between 16 and 18 to 1, right? So that the effect that I was showing is with small cereal rye, let it we generally, like I said, up front, our average biomass is about 1,200 pounds to the acre. And so all of that kind of nitrogen cycling effects that I showed is with cereal rye that had what would generally be considered, decently low C to N ratios. Yeah.
Um, okay. Then, okay. Have you tried to get rye to release their nitrogen to a corn crop through biologicals or microorganisms?
No, we haven't used it. I have not used any I assume that what they're asking about is the products that some people will spray to help break down like corn residues and things like that. No, we haven't done that.
Okay.
Um, yeah.
Okay. Here's if cereal rye gets too tall before termination, it can interfere with seeding. How do you adjust for that?
Well, that's a wonderful question. So some people, if it gets too tall, they'll choose to roll it down if they
Yeah.
have that ability, which then hopefully if it's laid down, if you have good row cleaners on your planter, hopefully it can open up the kind of the row for you there. But yeah, I mean honestly, that's one of the reasons why we kind of promote um, not letting it get that big, is because it can cause a lot of issues both with the planter and even just with the plants in general, right? Hairpinning and things like that. So I don't have a great answer for you. I suppose the best answer is try to control it before it gets
Okay.
away from you. And I know that's not always possible.
Okay, I'm taking my prerogative as a moderator. I'm going to ask two questions. These are coming from me. So one is,
Okay.
so I've seen people crimp it with that crimper. Now I'm thinking of
Yeah.
in north central Iowa, we got these big rollers that they go out, to push their rocks down with. Have you ever seen
hmm
anybody roll their cover crop with that if they're trying to knock it down?
I haven't, and
Okay.
I would be curious on whether that would work or not, right?
Yeah.
Because the crimpers, what they're doing is they're like kind of not they're not snapping the stalks,
Yeah.
right? But
Right.
they're
Right.
crushing the cells there to help
Yeah.
uh you know not allow things to flow in the plant anymore. So I would be interested to see if that
Okay.
would work or not. But I suppose if the question is just what do we do to it so that we can get it planted with less issues, maybe just rolling it over with that might help, but I don't know if it will actually kill it or not.
Yeah. Somebody said in there, rollers, it'll come right back up. I kind of wondered about that. Probably a silly question for me to ask. Okay, my other question was on your clover, Balanza,
Uh-huh.
is that clover? Do you have any data on the nitrate loss reduction with that? So, yeah, I mean, we have a lot of good data on cereal rye cover crops. Is there data
hmm
um, on any of the clovers there?
Yeah, that's a wonderful question. The short answer is no. The little bit longer answer is we're working on it. So hopefully in the next couple of years we'll have some good data, multiple years of data on how that can affect it. Yeah, because that is a real worry, right? I mean, I think, I mean, as well as I do that, um, like just think about a system with no cover crops at all, right? Just corn or soybeans. We can lose a pretty substantial, like up to two-thirds of what we would lose in a corn year during the soybean year, right? So uh, part of that might be because of the soybeans. A lot of it's probably because of residual nitrogen. But yeah, so that's one thing that we're working on because obviously it's one thing to promote it for one reason, but we need to understand the whole system.
Um, there's somebody asked a question. This is the yield loss seems independent of the cereal rye biomass. How does that square with the end sequestering explanation for yield loss? What else do you think could be going on?
Yeah, so I think well, it's I think it's twofold. Number one is yes, the cereal rye is going to pull some nitrogen out of the soil, but generally, I would say most of the time that's like residual nitrogen in the soil, right? Unless you are applying fall anhydrous into a living stand of cereal rye, I would say most of the time it's residual nitrogen rather than fertilizer nitrogen that the cereal rye is taking up, right? So that would be my first comment. So what I mean by that is that, you know, the essentially the crop should be getting the same amount of fertilizer, right? Because we're not necessarily interacting with the fertilizer, we're interacting with the soil nitrogen. That's my first comment. Second comment is that regardless of how big the cereal rye is, the microbiome has to work to break it down. And so, and the microbiome activity is tied almost exclusively to soil temperature. And so, by adding any amount of um, any amount of carbon to the system, you're going to excite the microbiome, and they're going to want to go to work breaking down organic matter. And so, whether that be cereal rye residue or it be organic matter in the soil, it's going to go to work breaking it down. In order to break that down, it has to pull nitrogen out of solution. And so, um, so it's going to happen. It happens. It happens even if you don't have a cover crop in the field, right? And so when you start adding additional carbon and things like that, it just exacerbates the issue. Um, yeah, and there could be other things tied to that as well, right? Like I'm not exclusively saying that. I suppose I did say that the yield reduction is because of nitrogen, but it could be because of other things, right? So cereal rye takes up all kinds of plant nutrients, right? So sulfur is one that cereal rye takes up a lot of sulfur,
Hmm.
and we don't get sulfur from the atmosphere anymore. So maybe there's a sulfur component to it as well, right? Maybe there's other components, but I do think that nitrogen is one of the larger issues.
Okay. Um, what do you think are some of the largest future research needs in related to investigating nitrogen and cover crops?
That's a good question. Um, so one thing that is needed. So I showed a slide on there of being able to, so I didn't really explain it that well. So the slide where I showed and I said only 14% becomes plant available. So what we did there was we actually used a like a form of nitrogen that has essentially a tracer built into it. And so we were actually able to track the nitrogen that went into the cereal rye, back out of the cereal rye into the soil, and then we can track that back into the following crop. Um, that's been done with cereal rye, and actually my group here at Iowa State is about to start doing that with all of the different legume cover crops as well to see if we're actually getting, if that less of an impact on yield from legumes is actually because we're getting nitrogen from the legumes or because we're not tying up as much because of uh, like the seed-in ratio of the cereal rye residue. So that's one thing is we need to understand kind of the nitrogen cycling um, of different cover crops. Another one is just continue to look at rate and timing and placement uh, and source of nitrogen to be used with these different cover crop species. So I've had several people tell me that they will broadcast AMS on top of cereal rye after they terminate it, and um, and they swear by it. I mean, I've not worked on it myself, right? But I think that could be something interesting to look at. Um, yeah, I mean, there's so much. Um, but yeah, and then like Dr. Helmers mentioned, the understanding how the non-grass species, so the legume species, actually impact water quality and things like that.
Okay. All right. In the interest of time, especially since I know you're up at Northeast Research Farm, maybe the last question here is, what's the microbial levels in these soils? Has there been any PLFA or soil health assays done on these fields?
Yes, there has been, and we didn't really see much of a difference. So the very kind of neat thing, I suppose it depends on your definition of neat, right? But kind of the neat thing that can happen with in our fields with the microbiome is that our microbiome will adjust itself to what it needs to be. And so what I mean by that is we had a student while I was at Purdue, there was a student who um, he did some DNA sequencing of the of specifically the bacteria. So he didn't necessarily look at the fungi or the viruses, but the bacteria in the soil. And he looked at a system with no cover crop, a system with hairy vetch, so a legume, and then a system with cereal rye. And they had never had cover crops on them before. And what he found was that basically at the time of like termination, which we did 2 weeks prior to planting our crop, the microbiomes were extremely similar. And then about 2 to 4 weeks after that point, he pulled samples again and then looked, and you could actually see the microbiome shift between these systems. So where we had the cereal rye, the they didn't change the size or the number of different species of bacteria. But what it did was the it basically shifted the microbiome to the largest portion, so the biggest what am I trying to say? Like, if you have a pie chart, right, the biggest slice of the pie was bacteria that are focused on carbon cycling versus where we had the hairy vetch. um, the biggest slice of the pie was bacteria that were actually nitrogen fixers. And so the microbiome can actually shift, and I'm not a microbiologist, but the microbiome can shift to meet the needs of what's in the field. And so it's yeah, I don't think that we actually manipulate the biology as much as we tend to think we do. I think more the macrofauna, so like your earthworms and things like that. I think that tends to uh, change quite a bit with having these different practices in the field.
All right. Richard, thank you very much for very informative webinar. Again, if you need a CCA CEU, please email Elena Whitaker, ALENAW, at iastate.edu by 5 o'clock today. Include your name, the name you entered to watch the webinar, and your CCA number. And tune in next week to hear a little more about insurance related to relay and double cropping. Again, thank you, Richard, for presentation. As always, the email again is ALENAW. So it's Elena, ALENAW, at iastate.edu. And yep, thanks again, Richard. And I hope people will reach out if they have further questions. As always, this will
Yep.
be archived on the Iowa Learning Farms website and on the Iowa Learning Farms webinar YouTube channel. So thank you very much for attending.